Welcome to Mathlink Academy, where we connect the dots. I am Mr. C, and in this unit, we're going to talk about antiderivative and also finding the indefinite integrand. So let's get started. For this lesson, I want to show a lot of examples to help you understand the antiderivative and the indefinite integral. Let's start off with a function. Let's say our function f of x is equal to x cubed. Now, let's say we want to find the derivative, which is f prime of x. That will equal to 3x squared. That's the derivative of x cubed. What we want to do, and I'm going to write it in a different way of our derivative, how we look at it. So we want to have the derivative. Let's say we want to find the derivative again of x cubed. This is how we write it with respect to x. It's going to be equal to 3x squared. What we want to do in this lesson, I'm going to give you the derivative, what is already the derivative, and you're going to give me the original function that gives us that derivative. So we're going the opposite direction, or we're going to say we're finding the antiderivative. Now, normally how we would do some things, I want to give you some rules, some basic rules, and I give you some more rules. And once you understand the rules, you understand how to go from one direction to the other. And there's a reason why we do that. You look at some of my future videos or some of my other videos, it show you eventually why we use antiderivative or find the integrand of a function. So let me talk about this integrand and how it looks. So going back to what I said before, this symbol is this is an integrand. And what we want to do, we want to find that function we're going to put in the integrand with respect to x, and what we're going to get in return is f of x, and normally we say plus c. And we'll talk about that a little later. And this is helping us find the antiderivative. Now let's go back to our previous example. We had y was equal to, or f of x is equal to x cubed. The derivative of this, y prime, would be 3x squared. Now, when we use the integrand to help us find this antiderivative, this is how you do it. I'm going to write it in blue. You say the integrand, in this case, of 3x squared with respect to dx, again, this is going to equal to the original function, x cubed plus some constant c. All indefinite integrals must have a plus a constant c. And I'll show you that a little bit later. So see the relationship. I went the other direction. Again, this is our derivative. And this is what we got out as an answer once we put it in the integrand. And then plus c is always referred to after our capital F of x. So let me show you some ideas of what we're looking at. Let me look at some things here. So let's say we'll find the derivative with respect to x of a constant. And we use c to be arbitrary. Any constant, 1, 2, -1, 5/4, pi. Pi is a constant. So derivative of a constant, we all know it's going to be 0. So in blue, if I write this as an integrand going the other direction, you're basically going to say, we're going to take the integral of 0 with respect to x, dx, you have to write that in there. It's equal to c. I'm going the opposite direction. Let's do another one. Let's say we want to find the derivative of 2x. The derivative of 2x is 2. I'm going to put in blue doing the integrand, finding the antiderivative. So we say the integrand of 2, in this case, we use 2 dx it's going to equal to 2x plus c. Now let's stop here to check if this is correct. So what we do here, I'm going to go back to what we did with 2x plus c, is you take the derivative of 2x plus c. What's the derivative of 2x? Is 2, the derivative of c is 0, and that gives me 2. That's how you check it. Let's go back to the top one. What is the derivative of c? The derivative of c is 0. So whenever you find that antiderivative, you take the derivative of that antiderivative, it should give you back what's inside, if you did it correctly, what's inside the integrand, okay? So that's the basic understanding of what we're setting up to find the antiderivative. So here's some basic integrand rules. Don't let it overwhelm you by looking at these basic integrand rules. You basically know this already. You just got to think about it going the other direction. So what I would say is look at the first column, our derivative column, or where we're differentiating our formula right here. I went over the first one and the second one, where we find the derivative of constants equal to 0, and the integration formula will look like this. We take the integral of 0 with respect to dx, or with respect to x, is equal to c. We did that one earlier. We also did the second one. The derivative of a constant times x is equal just that constant k. If we want to find the integration formula of that, we integrate just k by itself with respect to x. Dx is equal to kx plus c. Again, don't forget there's a plus c at the end. The one we're going to use is this power rule here. You already know the derivative of x to the n. So if I had 3x as my function, I already know the derivative y prime will equal to 6x, and that'll be our answer. That's basically the derivative. Now the antiderivative, I want to clear this, or we're looking at the integration formula, it's going to equal to x to the n plus 1 divided by n plus 1 plus c. That's one you want to know. That's like the power rule that we're using for integration. And then I'm going to show you some trig functions that we know, and then possibly some exponential functions. And so if you know the trig derivatives, you also know the integration formula for trig functions. The one I want us to make sure we understand is the power rule and how it works. And basically, that is the rule you want to know by heart to be able to do integrations using the power rule. So let's look at a function. Let's say f of x. Let's put a function inside the integral and see how we do it. It's equal to 3x squared. So I want to integrate that function. Let's just integrate it. I'm giving you a function, let's integrate it. So we say 3x squared dx. You must put that dx so you understand you do it with respect to x, because you can do it with respect to other variables. And the power rule for integration is basically this. It'll be x, and our n in this case is 2. We look at that exponent. It'll be n plus 1. That's our rule. So what is 2 plus 1 is 3 divided by n plus 1, which is 3. Again, same thing. Now, don't forget, there was a 3 up here. This green 3 is that 3. Then we say plus c. Never forget you put that plus c. Then what you can do, you cross cancel that. And so this will equal to x cubed plus c. Now, let's look at this. Let's look at this. What is the derivative of x cubed plus 3 to make sure we did that right? The derivative of x cubed plus 3, I'm going to put this in orange, is 3x squared, and the derivative of c is 0. Notice this. This is the same as this. So this is exactly the correct answer, and you must have that plus c, because a plus c, when you take the derivative of c, is equal to 0. So that c kind of just comes out. And we'll talk about it, makes families, but we'll talk about that later. So this is correct. Let me show you another example without having a constant in front of it. So let's look at a function. Again, let's do another function. Let's say we have x to the 4th. That's our function. F of x is equals x to the 4th. And I want to integrate that. So you just write down x to the 4th dx. And using the power rule of the integration, it says this. It'll be x to the, and this is my n is 4. And you say 4 plus 1 is 5. So it'll be x to the 5th divided by n plus 1. Again, 4 plus 1 is 5. Then you say plus c. This is the answer to this problem. Again, if you take the derivative of this, it will give you what we have inside the integrand. And these are indefinite integrals because we're adding plus c. So let's do another one. Then I'll show you some arbitrary ways of how to write it and understand some different symbols and formulas that we're going to use. Let's say we want to take the integrand of x to the 7th with respect to x, dx. Got to put that there. That would say, since n in our case is 7, we end up with this answer, x to the 8th divided by 8 plus c. We got to have that plus c. Now, if you take the derivative of this answer, because that's my answer, because I circle it, that's going to give me just x to the 7th. And that's how you find the integrand using the power rule. We use that kind of like the power rule. Arbitrarily, what you're saying is this. The integrand of a function with respect to dx is equal to capital F of x plus c. And this is our capital F of x. What I put in green right here. So when you take the antiderivative or find that integral, it's capital F. Unlike the derivative, it's f prime or f double prime. When we take the integral, we equal capital F of x plus c. Same thing before. This will be, again, capital F of x plus c. And then again before, this piece here will be capital F of x plus c. So that's using the power rule. Now going back to our basic integration rules, we just went over the power rule. This is what I'm put in the box. And then a little extension of it is you can have different functions and you can do them individually. That's what this is saying. You can do functions individually, different terms in the function, and find the integrating of that, or integrate that to find the answer. The next thing we're going to look at is using trig functions. We understand that the derivative of the sine is cosine. So if we take the integral of the cosine, it's going to equal to the sine of x plus c. Again, don't forget there's a plus c. We know that the derivative of the cosine of x is equal to the negative sine of x. So the integral of the sine of x dx is going to equal to the negative cosine of x plus c. And make sure you note that this is the antiderivative, or finding the integral of the sine of x dx is the negative sine of x, cosine of x plus c. Let's look at some more. We know the derivative of x, or the tangent of x, is equal to the secant of x, or secant x squared, or secant square x. And then so the integral of the secant square x dx is equal to the tangent of x plus c. So it's just going in the other direction. One of the other functions we have with trigs are these remaining three. If you know your derivative of your trigs, you also know the integration formula. What I want to look at is the e of x. This is one I think you'll like. The derivative of e to the x is e to the x. So when we integrate e to the x dx, it's going to be e to the x plus c. That's one that we can just really put in the memory bank and get that very simple. And then we have other ones with natural logs and exponents. That is good. One of the things that we want to make sure we know is the integration of 1 over x dx is equal to the natural log, or the absolute value of x, plus c. So I'm going to circle ones that we should already, and even put in a box that you can probably get very clearly if you know the derivative. Now, before we start combining all these different types of functions, let's go back and review the power rule. And then we'll use some of the trig functions and some exponents. So we have the integral of 3x dx is equal to, and what we did here was we took out the constant 3. You can do that. You can factor out a constant 3 out the integral. So you can factor out constants. So I took out the 3, and we're left with the integral of x dx. Now the integral of x dx, as I take that out, is the same thing as the integral of x to the first power dx. And when we take the integral, the n is 1. So it'll be 1 plus 1 is 2 divided by 2. Again, this 3 is being left alone to the very end. When you write the final answer, you can write it this way. 3/2 times x squared plus c, and that will be your final answer. So what I've showed you is you can take out constants and then just take the integrand of the variable with respect to x. So let's look at some examples in doing integration. So let's write some problems down. So here's some functions. F of x, and I also can say y is equal to. Let's say it's equal to 3x squared plus e to the x. And I want to integrate that. So I'm going to do this in blue. So here's my integrand, and I'm going to put down f of x, which is 3x squared plus e to the x. Put that in parentheses because it's one function, and then say dx. And let's integrate that individually. So we can integrate them individually to get our final answer. So in this case, I can say this is the integral, and right of this 3x squared dx plus the integral of e to the x dx. I can write it just like that. So I can split that integral, and not necessarily splitting it. What I'm doing is splitting the function into those two terms. Remember, those are integrals with respect to x. Now, once you start doing the integral, you don't have to always do this way. You can see the answer, and you can just write the answer out once you see it. So to do this, we can actually factor out a constant, dx. We'll just leave this alone, e to the x dx. And for this, we just use that power rule that we talked about earlier. So n in our case is 2, and so it'll be n, 2 plus 1 is 3. So we end up with x cubed over 3 divided by n plus 1, plus some c. But in this case, I'll do the c at the end. So the next one we do, I'm going to underline it in orange. We just do the integral of e to the x dx, and that will give me just e to the x plus some other c. In this case, I combine those two c's. I said a c1 and a c2, I get an arbitrary c. So don't forget, when you finish integrating, it'd be plus c. Now I'm not done, because what I can do, I can cancel out this 3 with that 3. And so my final answer will be x cubed plus e to the x, and then say plus c. Don't forget, you always need a plus c for an indefinite integral. And that's my answer for this problem. If you take the derivative, what's in the orange, it should give you what's inside the integrand to double check if you did it correctly. Let's look at some other problems. We could just do so many problems. So let's do f of x, and you give me a problem. Okay, that sounds good. Let's say 4x squared plus, and let's say this, let's put a trig function here, plus the cosine of x, and let's add one more, plus 3. So let's do this. We'll do it in blue. So we're going to integrate 4x squared plus cosine of x plus 3. Put that in parentheses because that's one function with respect to x. Therefore, what we have here, we can break this up individually or just do them together. So I'm going to do them individually, but I'm not going to show it to you. I'm just going to say it out loud. So for the first function, I'm leaving it in blue. For the first one, I'm underlining orange so we can see it. That just basically gives us 4x cubed divided by 3. For the second one, what is the integral of the cosine of x? The integral of the cosine of x will be the sine of x, the positive sine of x. So oops, let me put that in blue. And the integral of 3, just a constant, in our case, it will be plus 3x. And this is going back to the rule that I showed you earlier when we were on our slide. And then don't forget there's a plus c. So I ran out of room, I'm putting plus c there. So let me write down this answer. So the answer for this particular problem could be 4/3 x cubed, you can write it like that, plus the sine of x plus 3x plus the constant c. We got to have that plus c. And then we highlight our answer, circle it, or put a box around it. And you can always double check by taking the derivative, what's in the orange, and see if it matched, that derivative, whatever's in the orange, match with our original function inside the integrand. Let's do another one. Let's say we want to find, in this case, I'm going to just write the integral. Let's say we want to find of 2 sine x plus 3x minus 4 dx. This is our function. So let's do that one. In this case, we could take them individually, the integrand of each of these, the antiderivative. Now, since that 2 is in front of, I'm using the first one, 2 is in front of the sine of x, we can factor out a 2 and figure out what the sine of x is, integrate that. And so this will give me 2, we factor out the 2, and remember the antiderivative of this will be a negative cosine of x. So don't forget, that's a negative cosine of x. And so the next one, the second one, this will be plus 3. Don't forget there's a 1 up here. 1 plus 1 is 2. So that'd be x squared divided by 2. And then minus 4x plus c. That's our third piece right there. Now, how would you write this, Mr. C? Well, I would write it like this as a final answer. For the first piece, I would write it like this: a -2 times the cosine of x. So write it like that, plus 3/2 x squared minus 4x plus c. And that would be my final answer. Let's do one more for the road. Give me a good one, guys. Okay, that sounds good. Let's take the integral and we'll put some trigs in there. Let's say e to the x minus 5, and let's say minus the secant square of x dx. So we have exponential with a constant with a trig function. We're going to do them individually. Start with the first one. What's the integral of e to the x? Integral of e to the x is just e to the x. Integral of a -5 will be minus 5x. And who knows this one? The secant square of x. So you got to think, what's the derivative that gives me that? Right, that'll be the tangent of x. And remember, be minus tangent of x since there is a minus sign in front of that. And then you say plus c. Again, circle it. And then if you want to check it, again, you always can check your answer. Take the derivative of what's in the orange and see if it equals the function that's in the integrand. So these are some basic rules of how to find the antiderivative or also finding the indefinite integral. Again, go over the video again, look at some of our supplementary material that is on our Mathlink website, and hopefully this helped. Again, let Mathlink bring it together.